Hello, this is Nick FV, and in this video we're going to create a static simulator. Basically, we're going to set up a truss and apply some forces to it and see how it reacts. So let me just sketch up a truss here. So this is a simple truss, but for this simulator, we're going to actually model each one of these linkages as a spring so they can deflect and contract. We're going to pin this side, and we're going to make this side a roller. And when we apply some forces to it, it might look like this. And we're going to see some reactive forces like this. And the pinned joint could have an X component. Now to set up our formulas to model this, we're going to use Newton's laws of motion, where Newton's second law actually is not F equals ma, but it's actually the sum of the forces is equal to the change in momentum with respect to time. So momentum is actually mass times velocity. And assuming that mass stays constant, which it is for this simulation, you can just take the derivative of velocity, which is acceleration. And that's where you get F equals ma, where F and a are vectors. On the other hand, we also want to model these linkages as springs. And using Hooke's law, you can say F equals negative kx, where F is the force exerted by the spring, k is the stiffness, and x is the deflection of the spring, where F and x are also vectors. So now we can actually put these two equations together to create a formula for each one of these joints. So we can say the sum of the forces in one joint is equal to the sum of negative k times x for each one of these springs. And that whole thing is equal to the mass of that joint times its acceleration. So if we want to simplify this and solve for the acceleration, we can say A equals the sum of negative kx all over m. So that represents a single joint here. So we'll be using this formula for our simulation. If we want to simulate this through time also, we can integrate acceleration twice. So if you integrate it once, then you get the velocity of that joint. And if you integrate that one more time, then you get the position. So based on the forces that are applied, these joints will actually move around in the simulation because of the compression and the tension on each one of these joints, or on each one of these links. So with that, we're going to start writing the simulation. So over here, I've set up a project folder, and I'm going to create a project with npm. I'm also going to do a git ignore. I'm going to use Bun for this project, and I'm going to install two of my packages, one of them being SMAF, and the other one being Graphico for graphics. SMAF contains this vec3 class to represent a vector in 3D space, but you can also use it for 2D space as well. And it has plenty of methods that we're going to use in this project. So I'm going to start this project. I'm going to install those dependencies. And I'm going to clean up this package JSON and write some scripts in here. So this will be our final git ignore, and this will be our final package.json. So I'm going to go ahead and commit these files. So the first thing I'm going to do before I get started with the simulation is just create a simple HTML page and see if it can load a JavaScript file. So I'm going to build my project with bun dev. So it created this dist file with an index.js, which is the build output. And I'm going to copy the path here and launch it in my browser to see if it works. So I need to inspect, go to the console, and I see my loaded message. So I know it's working. So I'm going to go ahead and commit these files in the meantime, and then we're going to start building the project. So like I showed earlier, we're going to need to create two objects, one of them being the joint that connects multiple links, and the other being a link that connects two joints. So first, I am going to create in index.ts. I'm actually going to create a canvas first, so we can actually draw some of these and render them to the screen. And make sure to clear the canvas on every loop. First, I'm going to create a joint. In order to be able to render it, we're going to need to pass in a position for this joint. And we're going to use that vec3 class provided by SMAT. Okay, so I've created a joint that just renders an outline of a circle. So I'm going to see if I can render that. Okay, so if I run that with bun again, we should maybe see that in the canvas. So if I refresh, now I can see that joint was rendered. So now the next step is to, well, first I'm going to render a second joint. So now I have two joints here, and now I want to link them together. So I'm going to create a class that looks very similar to this one, but instead of rendering a circle, it's just going to render a line between 2 points. Now instead of passing in 2 positions, I'm actually going to just pass in 2 joints. So let's give this a try now. We're going to try to render this link. So if I go back into our index file, now I can create a link. And I can pass in the 2 joints I created. And then I can draw that. And now I'm going to see if it rendered. And it did. But you can see it actually is kind of covering over the empty space in the middle of these circles. So we can actually fix that using some of the functions in this vec3 class and a little bit of geometry. So I'm going to do that in here. So now we have a start and end position that has some kind of offset here. And so I'm going to use this instead of the joint 1 and joint 2 position. Just for the sake of rendering, so we can see it easier, I'm going to change this color for now. And now when I refresh this page, now we can see that this link doesn't overlap with the empty parts in the middle of these joints. So now that we have the rendering, the next step is going to be to work on these formulas. So that'll be in the next video, and I'll see you there.